Hi students, how are you? So today we look at 9.3, continue thinking about these vector functions. So to begin with, take a couple of minutes, see if you can figure out what to do with this vector equation, where we've got the position of an object at time t described in terms of I and j components. For part A, it talks about r dot, so the first derivative with respect to time, and r double dot, second derivative with respect to time. Have a go at that, and then we'll go through it in a second. Okay guys, so we'll go through that in a moment, but before we do, in case you haven't finished it, I just want to show you a solution to the last part from yesterday's lesson. So I'll scroll through this pretty quickly, and if you weren't sure how to do this one, then you can take a look at my solution. Pause the video if you need to. Okay, so that's it for 9.2. On to 9.3, and what we're looking at is first and second derivatives, velocity and acceleration, when we're talking in terms of vectors. And, you know, the takeaway really is that it's exactly what you would expect. And I think we talked about this briefly yesterday in terms of how you would expect you to be able to just to differentiate and integrate by component, and you can. But what we're going to do is just look at that formally with a quick proof. What we can see here is we've got a trajectory or a path, which is a vector r of t, and just like we do with differentiation with a standard equation, we're going to just move a small distance h along that curve, and we're going to look at the derivative defined as the limit of the change in y over change in x as h tends to 0. And bit of a warning, I'm going to write quite small here to try and get this in, because we're going to squash in quite a lot of stuff about limits. But using what I already know about the definition of a derivative, that's going to be the limit as h tends to 0 of r of t plus h minus r of t all over h, so change in y over change in x. And what we're going to do is we're just going to expand our definitions for r in terms of I and j components. So r of t plus h would be, that shouldn't be underlined there, but x of t plus h I plus y of t plus h j, then minus, for the r of t, x of t I minus y of tj. And that's the limit of that as h tends to 0. And then what I'm going to do, maybe you'd expect this, is just gather together the I and the j components. So I've got the limit as h tends to 0 of x of t plus h minus x of t all multiplied by I, and that's all over h. And then I've got plus y of t plus h minus y of t all multiplied by j over h. And then we know something about limits, which is that if I've got a limit of a plus b, that's the same as the limit of a plus the limit of b. So formally, I can write this as two separate limits. If I'm being really formal, I do need to go through this process. What I'm going to do is take I out of the limit, because it's not necessary, it doesn't change, it's like a constant vector, it doesn't change with h. And then I'm going to do the same for the j component. And then as a final step, well, what I've done it with my rearranging here is I have, with this limit, well, that is my definition of x dash. of the first derivative of x, and this is my definition of the first derivative of y, giving me exactly what I expected and the result above. The first derivative of a vector is this, you can do component by component. Once we know that, well, we can apply various different rules and properties that we've got here, and really those are just exactly what you'd expect. So, on to the question which I asked you guys to do right at the beginning. So, the dot, by the way, ideally they would have gone right over the top, is first derivative with respect to t. It's kind of a special type of dash, just for time. So, a dash just for time. You can write with a dash as well, that applies to anything, but the dot tells you that it's time you're talking about, and that's why we have a different symbol. So, for part A here, if I find the first derivative, I'm going to differentiate 2 cos, and I get minus 2 sine of t. That's my I component. Differentiate 3 sine, and I get 3 cos. So that's my first component. Then it wants the second derivative, and we can see this is working out kind of straightforward. I've got minus 2 cos of t, sine differentiates to cos, and I've got then minus 3 sine of t j, because cos differentiates to minus sine, and I guess it's worth me noticing here that the second derivative, the acceleration in this case, is just the negative position vector, so minus r. By the way, this property here, we've got motion in a circle, or in this case an ellipse, and the acceleration in that case is always towards the center of the ellipse or the circle, and that's really the position vector in this case, because the center is 0, 0. So what's happening here, if you've got any motion in an orbit, you know, if you think about putting something on the end of a piece of string and swinging it round and round in a circle, that object is always accelerating towards the center. And we can see that in the equation here. So the acceleration towards the center. The slightly more technical part of this was to find the gradient at the point xy. So they're after an expression for dy by dx. And best thing to do is to work out dy by dt and dx by dt, and then use the chain rule to relate them. So dy by dt, if I look at y, is going to be 3 cos of t, and then I'm going to multiply it by d1 over the reciprocal of dx by dt, so that's 1 over minus 2 sine of t, and so my gradient is going to be minus 3 over 2 cot of t. And I guess just something to notice there is that the gradient, we can see when it's going to be undefined. Gradient is undefined when the denominator is equal to 0. So in this case, sine of t equals 0. So t equal to k pi, k a natural number. All right. So, hopefully that's all right. Moving on to the next page, and what I'd like you to do is try the exam question really quickly before we then go on to anti-differentiation. So, give yourself a couple of minutes, see if you can get to the answer. Okay, so hopefully you've tried this now. So just using the chain rule again, dy by dx is dy by dt times by dt by dx. So that's going to be minus 2 sine of t times 1 over 4 cos of t. So the gradient is minus a half tan of t. And then it's asking for that to be it's asking for the value at a very specific point. So if x equals 1 and y equals root 3 plus 3, I'm going to substitute those into my coordinates here, and that's going to tell me values for sine and cos. So sine of t is going to be a half, cos of t is going to be root 3 over 2, and so it's looking like we're in the first quadrant with our angle, and in fact we recognize that that's going to be t equals pi over 6. So drawing the quick triangle, pi over 3, 2, 1, root 3, pi over 6. The gradient at that point is going to be minus a half times tan of pi over 6, which is going to be opposite over adjacent, 1 over root 3. So our answer is minus 1 over 2 root 3. Gradient at that specific point on the curve. Okay. Skipping on to anti-differentiation, same thing. We work component by component, but the key thing to think about here is that plus c is a vector. You can see it's bold here, and when we write it, we have to underline it. So knowing that, try the question. C is a vector. Try and integrate given the initial conditions here. Okay, you've had a go, so let's have a look at it. Integration of 10i would give me 10ti. Integration of minus 12k would be minus 12tk. And then I've got to add a plus c vector. I'm going to substitute in the initial condition they give me. T is 0, both of these components are 0. So this tells me that c must be that vector that they've given as in the initial condition. So c is 30i minus 20j plus 10k. Notice how I'm underlining everything I need to underline. And this tells us then that if I split it into components, r dot of t, that first derivative, the velocity, is going to be 10t plus 30i minus 20j plus 10 minus 12tk. Happy days. Then for part B, I'm going to integrate again. So integrating 10t would give me 5t squared. 30 would give me 30t. That's my I component. I've got minus 20tj. And then I've got 10t minus 6t squared k. But I've got my plus c, plus d, to use a different letter. It then tells me that r of 0 equals 2k. So therefore, d equals 2k. Underlining everything I need to underline. So r of t, to write the whole thing out, 5t squared plus 30ti minus 20tj plus 10t minus 6t squared plus 2k. Good stuff. So, taking that on, there's 2 questions just to finish off on the next page. I'd like you to try both of them, 2 past exam questions, have a go, and then we'll go through them in just a second. Okay, so you've had a look at this, very similar to the last one, just introducing a little bit of trigonometry. So I'm going to try and integrate once, and I'm going to get minus 3 over 2 cos of 2t I plus 4tj, and then plus a vector c. I substitute in r of 0. That gives me 3 over 2i. And then I just need to be a little bit careful with this, because it's not as simple as maybe we'd assume, because we've got minus 3 over 2i. Cos of 0 is 1. And then we've got plus c equals 3 over 2, which tells me that c equals 3i. So that means that r of t is going to be 3i minus 3 over 2 cos of 2ti. So we could write that as 3 minus 3 times 1 minus a half cos of 2ti plus 4tj, like so. And then the final question, perhaps this is the most interesting one of the lot. So we're talking about this water skier moving in a straight line across a lake, and we're looking at a position relative to a fixed observation point, and we can see the equation here given for the position. And the first thing I notice is that I is just 7.5t, so that means a constant speed in the I direction, and the I coordinate or the X coordinate just increasing gradually, but the interesting stuff happens in the Y direction or with the J component, which is going to oscillate because of the sine term. So reading a little bit about exactly what it's saying I is the direction of motion of the speedboat, and J is a unit vector perpendicular to the left. So that's going to look something like this. So my speedboat is heading this way in the I direction with J off to the left. And then if we think about trying to draw this, if I have my axes, this is my X direction, this is my Y direction. I've kind of got this central point at 50, and then I've got 60 and 40, because sine is going to oscillate between 1 and minus 1, so this J component is going to oscillate between 40 and 60. And what's going to happen is we're going to start off here at, if t is 0, we have 0, 50 as the coordinate, and then to begin with, because this is negative, it's going to head down, then back up, then down, then back up, and we get the oscillation. So what we can imagine here, don't know if you guys have ever done water skiing or wakeboarding, but the way that it's happening is we've got this boat that is probably just moving along the 50 line, and then the water skier is moving left and right behind the boat, so up and down. So that's what I would say the path looks like. Then the final thing is state the times when the acceleration is 0. So we can quickly find the second derivative. First derivative would be 7.5i minus 5 pi over 3 cos of pi t over 6j. 5 pi over 3 just coming from the 10 cancelling with pi over 6. And then so the second derivative, nothing in the I direction, and then 5 pi squared over 18 sine pi t over 6j. That's an expression for the acceleration vector at any particular point. But the question just says, well, when is it 0? And if it is 0, then sine pi t over 6 must be equal to 0, which tells me that t must be a multiple, or pi t over 6 must be a multiple of 2 pi, which means t has to be a multiple of 12. So 12k, for instance, where k is a natural number, 0, 1, 2, 3, 4, etc. So, sorry, that doesn't include 0, that's bad of me. An integer. K is an integer, which includes 0. Z for integers. The difference between n and z is the natural number doesn't include 0, which was a mistake. So there's my answer. Alright, almost there, 20 minutes in. Final thing I want you to do is just have a look at a quick multiple choice question, see if you can get the answer to it, and we'll wrap up. Didn't mean to do that, put that back. Try this question. Give yourself about 90 seconds. The correct answer, I'm going to reveal it now, pause it if you don't want me to. Correct answer is E. Okay. On your contract, you can see all the questions that you need to do for 9.3. As always, let me know if you've got any issues at all. Otherwise, I'll speak to you soon.